Hi, so we're going to go over this sheet that we did in class today for those that missed it or if you need extra help. So let's go ahead and get started. The first slide has the first question. All of the work's already done in this video, but I'll walk you through the steps. So Radon 220 has a half-life of 51.5 seconds. Suppose a sample originally contained 300 grams of Radon 220. How much time has passed if the sample now contains 37.5 grams? So we start with our 300 grams and we cut it in half and cut it in half and cut it in half until we get to our goal amount, which was 37.5. So we see that we've cut it in half 3 times. So we can go one of 2 ways. We can either take 3 times the half-life of 51.5, and that gives us 154.5 seconds right here. Or we can, instead of writing 1, 2, 3, we can just start counting by 51.5s. So we have 51.5, and then 103, that's 2 times 51.5, and then 154.5, that's 3 times 51.5. Either way, you end up with the same answer. So how much time has passed? 154.5 seconds, which is a little over 2 minutes. Okay, number 1, after the example problem, there's 600 grams of radioactive iodine-133. The half-life of iodine-133 is 21 hours. How much of this radioactive substance would exist after 21 hours, 42 hours, or 126 hours? So keep in mind that the number after the element is irrelevant to the question. It doesn't matter. So let's start with 600 grams. We cut that in half and in half and in half and in we just keep going. And then we start looking for where we can fill in blanks. So the first half-life, or the first cut in half, is our half-life, the 21 hours. So after 21 hours, we've cut it in half once. 600 cuts in half to 300 grams. 42 hours, that's 2 half-lives, or 2 times 21. So after 42 hours, we would have cut it in half again. That's 150 grams. Now, 126 hours, that's 126 times 21, or I'm sorry, 126 divided by 21, that gives us 6 half-lives. So we cut it in half 1, 2, 3, 4, 5, 6 times, and we're left with 9.375 grams. So this would be 1, 2, 3, 4, 5, 6 half-lives. Okay. Number 2, half-life of the radioactive gas Radon 220 is 51.5 seconds. Suppose a sealed bottle contains 100 grams of Radon 220. What mass of Radon 220 will still be in the bottle after? And they give us various times. So again, start with your maximum amount of grams. That was the 100. And cut it in half, and cut it in half, and cut it in half, and cut it in half. And so we see after 51.5 seconds, that's 1 half-life. We would have 50 grams left. 103 seconds, that's 2 half-lives. So we have 25 grams left. And 257.5 seconds, that's 5 half-lives. You can see the work here. You just take your time divided by the half-life, and that gives you 5. So 5 cut in halves leads us to 3.125 grams. Next one. Radioactive decay can be measured. One type of measuring tool gives a reading called a counting rate. A sample of radioactive material initially produces 2,000 counts per second. 4 hours later, the same sample produces 500 counts per second. What is the half-life of the sample? So we have 2,000 originally, cut that in half, that gets us to our 500. So we've cut it in half twice. So if 4 hours is 2 half-lives, then that means 2 hours is 1 half-life. So the answer to the question, what is the half-life? 2 hours. Next one, carbon-14 has a half-life of 5,730 years. What fraction will remain after 23,000 years? So we're talking fractions. So instead of amounts, we've got fractions. So we've got 1 cuts in half to 1/2. That'll be 1/4, then to 1/8, then 1 to 16th. So instead of writing 1, 2, 3, 4, 5, or 1, 2, 3, 4, we can count by 57/30s. So when we get to about 23,000 years, that's a 16th. Or we can go a different route and say 23,000 divided by 5,730, that's about 4 half-lives. So cutting it in half 4 times leads us to 1/16th. Last one. I have 15 seconds before I cut off. We've got carbon, which is 5730. An eighth left. 1, 2, 3 cut in halves from the previous question. That's 3 half-lives times 5,730. That's 17,190.